All right. What's up, everyone? Hopefully, you all have some plans for the weekend. Hopefully, some coding. Anyways, let me know how you guys like the screen. I changed my setup a bit. Hoping that this is going to be easier, for you guys to read. Um, so yeah, let's see how this goes. Okay. So hopefully you guys can hear me, correct? Okay. All right. I have a bit of a delay on the stream. Um, but anyways, let's focus on today's agenda. And today's agenda is to finish up the SQL logic. So that's what we're going to do. Um, so first let's talk about what we've done so far. So in index.js here, so here's the entry point into our entire applications. Let me increase this more real estate. So we have this index.js. This is our entry point. There's a lot of things that need to be changed here, but so far this is what we have. We created a setup function, okay, that basically allows us to run a command, an exec command, and then I explained that the exec command, okay, starts up a whole new shell and it takes some time to process. So it's not immediate. And I was able to prove that because we called this exec function, we passed it the appropriate parameters, and then I had a simple log over here. And the log executed before any of this code. So I was able to prove to you that you cannot, with exec commands, in any of these types that have callbacks, there's no guarantee of like when it's going to execute. It can be right away or it can take some time. Okay, that's why we call these callback functions. And the reason why we call them a callback function is because you're going to pass a function that'll be called when you know when data or whatever it is that you're trying to do finally is able to resolve. So again, it can take some time. So what I ended up introducing was this concept of asynchronous programming, right? So the asynchronous programming um, in JavaScript, we have this concept called promises. Basically, a promise is a way to be like, okay, hey, I'm going to execute some code and it's going to take some time, but I promise I will resolve in the near future. When is that? It depends on how long it takes, your code to execute. So it can be, sometimes it can be right away or it can take some time, but eventually it'll get resolved. So you get a promise that at some point, something hopefully will either get resolved or get rejected. So we introduced this concept of a promise, which allows us to do asynchronous programming. So the way a promise works is it takes one parameter, okay, and that parameter is just a function. That's all it is. It's just a function. But the function must take two arguments. One is called resolve, the other one is reject. These two arguments are themselves functions. The resolve function you should execute if and only if the code, your instructions here have, been executed successfully with no errors. You then execute resolve, excuse me, and optionally you can pass in some parameters, whatever it is that you were expecting. Okay. You then have this other parameter, reject, which is itself a function, which you should execute if and only if the code that you have possibly errored out. Okay, so we cannot resolve this thing successfully. Okay, so we use the reject. Okay, so we do not throw in here, we use the rejection. If there's any piece of code that you're going to write that could throw, that's a possibility that could throw, you should wrap it around a try-catch block and then call reject. You should not allow any code that you're going to execute inside of your promise be throwable. You should capture it inside of a try-catch and then explicitly call reject. That is probably one of the best housekeeping tips I can probably give you when it comes to promises, because you want to control the flow. You want to know if something gets resolved or something gets rejected. If a piece of code just, throws, there's no way for you to handle it, right? It'll just crash, and we want to have a way to handle this. And so we're going to speak to this a little later. So when you have a promise, one of the cool things you can do is you can use one of these new keywords that we just saw, which is await. The problem is you can only use await in a scope that is asynchronous, that has been tagged asynchronous. So our database setup is a function that happens to be asynchronous. Okay, so you need to tag it using the keyword async. Then inside of the body, you can use the keyword await. C# has a very similar syntax. Literally tag your function or method as async, and then you can use a thing called await. Okay. All right. I believe, does Java have something like this now? Honestly, I don't know if Java has something like this, but I know C# does, and that's the only language I care about. Okay, so now that we have that, again, this could throw, right? Because if you call reject, it basically throws, so we need something to catch it. So we use this try catch here. We tried to run, MySQL command, which is a promise, okay? So we await it. You do not call it like a function, so don't do this. Don't do that, okay? Because it's not a function, okay? So we just say await this thing, which is a promise. We await it, okay? And that's it, okay? Now this thing could get rejected because it's possible that when we try to execute this piece of code right here, which again, this is a command, that maybe something's wrong with the schema file, you misspelled it, or maybe you have a permissions issue or some other thing. So it's possible that it can get rejected. So what we want to do is we want to capture that rejection, okay, here, and then we want to control the flow. So here we will ourselves throw. So that's fine. So then it comes to, okay, so what the heck is database setup now? Well, database setup is a function that is tagged asynchronous using the keyword async. So because of that, database setup is itself a promise. So database setup is a function, so we must invoke it using, parentheses. It's a function. But the thing is, it returns a promise. Now, you would ideally use the keyword await. The problem is that the scope that we're in, you can see that there is no function. We're inside no function. We're just inside of a file. Node.js does not support global scoped async. You must wrap it in a function. Now, there's a couple of ways around this. One is using something called an iffy. That is an iffy. Immediately. Yeah. So this is what's called an immediately invoked function expression. Okay. I probably spelled immediately wrong, but it doesn't matter. So it's just immediately invoked function expression. So what's really cool about JavaScript is if you use a parentheses, you can contain any expression you want. For example, 1 plus 2, that's an expression, right? This is an expression. It's not an equation, okay? It's an expression, just like in mathematics. This is an expression. It doesn't become an equation until you assign it to something, or you give it into a function. Then it becomes an equation. Equation meaning there has to be an equal sign somewhere, right? Like, var x equals something like that, right? but you wouldn't do it this way. So inside of here, we have an expression. Now, the really cool thing is, how I've talked about this before, is that functions are what we call first-class citizens. They're just data. It's just a data type. A function is just a data type. And so because of that, in JavaScript, we can leverage the fact that functions are first-class citizens, so we can pass them to other functions, and we can treat them like any other data type. Okay, like you would an integer, a string, etc. So you can pass a function into a function and all these kinds of different things. But one of the cool things is that, well, you can create a function expression. So if inside of this parentheses we can contain an expression, then if a function can be an expression, then can't we just type out a function inside of this expression holder? And the answer is yes, yes we can. So there's a couple of ways you can do that. Though, one way you might see sometimes you'll see some people, do it the old way, which is like function, whatever, and then there you go. That's a function. This is in fact a function that is contained inside of these parentheses. And so this entire thing is a function expression. Okay, and we can assign this to something. So like var x equals, okay. And so now if we hover over x, it's a function type. See that? It's a function. It's specifically what we call an anonymous function because this function has no name. It's anonymous. What is this function called? I don't know, but all I know is that this variable x happens to be, assigned this function expression. So you'll see this a lot. Usually when you do something like this, you do something like a const or whatever, right? Because it's supposed to be a function. But now you're capturing the function inside of a variable, and then you just pass it around like anything else, okay? But sometimes we don't want to assign it to a variable. It just doesn't make any sense. It's kind of like a throwaway. We don't want to give it a name because it's like, well, what do we call it, right? Sometimes you run into those situations where it's like, I don't know what to call it. I'm just trying to scope something into a function, and I just want to contain it right here. So I don't care about giving it a name because I'm never going to invoke it ever again, just this one time. So if that's the case, if you don't want to assign it anything, then how can you execute this? Well, if this entire thing is just a function expression, meaning it's just a function, then it's logical that we just execute it like this, right? Because this whole thing is just a function. Everything inside of these parentheses is just a function. So if we add the invocation, using the parentheses, then we just executed this. And so I can say console.log, and we'll just do something like I am an iffy, and immediately invoke the function expression. So let me comment all of this out right here. Okay, and let's run this. It says I am in iffy. Oops. I am an iffy. There we go. I am an iffy. So notice that this function has no name. It has absolutely no name. Okay. We captured it inside of this expression using parentheses because that's what parentheses can do. They allow you to hold expressions, kind of like you do in PEMDAS. It's just an operator to contain expressions. And because it just so happens that the expression that is contained inside these parentheses is itself a function, then it stands to reason that we can execute that right here. So if I want to have like a variable here called, like, let's say, I don't know, let's call it message, okay? Then I can log that out, console.log message. So I can pass arguments in here. This is a message, right? Because it's just a function, so I can still pass parameters into it. It's just a function. It just looks a little different. See, this is a message. It just looks a little different. Now, again, you might see it like this sometimes. The newer way to do this is just using an anonymous function, or what we call an arrow function, something like this. So you might see it sometimes done like that. And if we run this, you get the same result. This is a message. Okay, you can pass multiple parameters. Again, this is just a function. This whole thing right here is a function. That's a function. It's just inside of an expression. We're containing inside these parentheses. Now, what's really cool is that we can even mark this as asynchronous if we wanted to. Okay? So this function expression happens to be containing an asynchronous function. When we invoke it, even though we ourselves are not inside of an asynchronous context, the way JavaScript works is if you invoke an asynchronous function, this will run as if it was asynchronous. So it'll just run. The problem is like when we get to this line, if you execute this, it'll just keep going. It's not going to wait for this. I guess you could call it the the program pointer just keeps going. And that's why I said it's kind of like threads. That part goes on its own. So I can show this, I can prove this to you by saying console.log, hey, and then I can do something like set timeout. I'll do a function here. So set timeout says, hey, run this function after some time. So we'll wait 1,000 milliseconds. And I have to wrap this inside of a promise. So I'm going to say new promise. Remember, the promise, you feed it a function that you can resolve and then reject. And then everything inside of the curly braces is the function, or I mean, is the code that's going to take some time. So here, this set timeout's going to take some time. But once it happens, I want it to then resolve. So I want it to be done. Okay? That's it. I want it to resolve at some point. Okay, cool. And so all I wanted to do here is after 1 second, I just want to log the message. Okay? Just want to log the message. That's all I want to do. Now I created my promise object. I said new promise, so we have this thing dangling here. Now, one way you can do is you can obviously assign it into a variable, how we did over here, MySQL command equals new promise, and then you can await it. Or we can just call await here, because this is just going to return a promise, which is awaitable, and I'm just going to await it. And the only reason why I can do this await, is because I'm inside of a asynchronous context. So await is valid. So again, like I said, once you execute this is inside of this function expression is an asynchronous context. The function pointer or the program pointer is not going to stop here and wait for this to execute. It'll keep going. So we should see hey, and then we should see after 1 second, this is a message. Okay, so let's try it. Node index. It says hey, and then you see that it hung a little bit, and then it says this is a message. You see that? So like I said, even though we are invoking this function, because the function happens to be asynchronous, we don't stop. The function pointer, right, just keeps going. It's like, okay, you invoke this function, it's asynchronous, that's going to go into some event queue. And then here we just keep going. We keep going. We keep going. We don't stop. We keep going. And then this eventually will come back. It goes into what's called an event queue. And once it's ready to come back, then the function thing will come back here and then start executing whatever code you have in here. How does it know to come back? That's the part of the resolve. If you don't call resolve, this asynchronous task just stays somewhere in limbo. Until you call resolve, it just stays. You basically await there forever. Now, now what if we, well, I think, does that make sense, everybody? Is everybody understanding that part? How we can do this right here? What all of this is doing? Because essentially we're going to leverage that in order to clean this up, because this looks a little dirty. The whole point of asynchronous programming is to prevent us from having to have callbacks. Now, callbacks sometimes is a good thing. Sometimes it can help us. Sometimes we have no choice. In this case, I want to clean things up. So I want to use some async code here. So I just want to make sure that we're all on the same page. So if anybody has any questions, please let me know if any of this is confusing. If not, I will just move on to the next thing. Okay, nobody has any questions? Okay, so we'll just move on. So now let me, I'll keep this commented out, and then I will start this. So again, we know that database setup is asynchronous, right? We know it's asynchronous. So what we can do is we can just say, so John's asking, is there a difference between reject and rejects? Reject and rejects. I don't see a rejects. I don't. Can you be a little bit more specific? Again, you can call this whatever you want. It's just, it's usually more, you know, the callback just calls these things resolve and reject, but you can call it whatever you want. You call this apple and banana. As long as you understand what apple and bananas are, remember, these are just identifiers. As long as you understand what each identifier is doing, what it's actually identifying, you can call it whatever you want. It's just, it's, you know, I would say it's more acceptable to call them resolve and reject. You could also, if it makes more sense, you could also call this, you know, success and failed. That's totally valid. Whatever works for you. But I don't know what you mean by reject and rejects. If you could be a little bit more specific there, I can probably help you. Okay, so here we have our little iffy. So what I'm going to do now is, this is going to take no parameters. I mean, you could do parameters, but we're not going to do anything. When doing resolve, rejects is auto-filled after. Okay. Oh, I've never seen resolves. I mean, rejects with an S. Auto-typed. If you hover over promise, it's always called reject. I'm pretty sure. New promise. Yeah, see, it's called resolve and reject. I've never seen rejects. Okay. So hopefully that clears it up. All right. So again, our database setup is asynchronous. So we just need to await it. So we're inside of an async function, so we can await something. So all we have to do then is just say await database setup. And database setup is itself a function, so we have to invoke it because this function, as you can see, returns a promise. There we go. Look how clean that looks. Then having all this other stuff right here, this then statement. We don't need the then statement. So we say await database setup. Okay. Now, the problem is that database setup could get rejected, meaning it could fail. Something can throw. For example, here we have a clear throw, fail to set up database. So it's possible that when we do the database setup, that it throws. So being the good programmers that we are, we don't want it to just explode. We want it to explode, but we want to let it explode, but in a contained fashion. So we can say try. And we can just stick that right in there and say catch. We will catch the error, whatever this ends up being. Console.log e. Okay. And in the case that something throws, we can even kill the project ourselves. We can kill it. So the way you kill it in Java, you would do something like system.exit, and then you can pass in a code or whatever. In Node.js, we say process.exit. Okay, and then you can feed it a code if you want to. So we'll say exit -1, so we know that, hey, this thing died with some kind of error, right? So there we go. Okay, so now we're just going to await database setup. Okay, and that's it. Very clean. Look how clean this looks. Okay. Now the next thing is we have our REST stuff, right? We have our Express application. So what we could actually do is we can create another function here called our what we call this. We can call it main. No, I can't think of a good name. We'll just call it main. Okay, there. We'll call it main. And this is going to be the bulk of our code here, which is just this, right? So we'll just copy that, paste that. We've got to uncomment all of this. And then let's format this correctly. Okay, cool. So our main is just a function that's going to basically just set up our application. That's all it's going to do. You can call this whatever you want. I'm just going to call it main. All right, so if everything goes well, right? If everything goes well here, we will then say, okay, execute main, right? That's our main project. So you look at the cleanliness of this. Look at that. See, here we had code that was directly embedded inside of this then, right? This is a problem. There's no isolation here, so this is it's kind of messy. But now we put our application logic inside of a function called main. In fact, we can even go a step further and strip this out, put it into its own file, and then bring that file in and then execute it. That's another option, which probably we're going to end up doing. Okay, so from here, after we have this database set up, we can even go as far as saying, okay, if everything goes well, let's do a little log. So if everything goes well, we're going to say console.log database setup complete. Okay. And then in here, what we can do is, if everything goes well, it's going to say listening on port blah. Do a period right there. Cool. And that's it. And that's our setup. That's a whole setup. So that's very small changes here. So you can see the difference. Look at that. Monstrosity. Like if I had to add more code, it would have to be stuck in here, which is not a good thing. Here we just move things around a little bit. So this is essentially, this is our entry point. We try to set up our database, and then if this fails, we kill the entire process. It's done. Okay? Because our application has a strong dependency with database, right? So if this fails, what's the point of even running your Express application? It's not going to work. So we need to die immediately. Okay, so this is a nice way to, structure your entry point. There's a billion different ways to do this. This is just, what I find to be useful. Okay, so the inside of main is supposed to be our Express application. Now, what we did on Wednesday was I just did a quick and dirty connection in here. I created a connection with our database called Bidder. I then created a MySQL user service, and then I called create user, and I passed the data in, and that's all I did. Okay, that's essentially all I did. I didn't do anything else other than that. Now, does this work? Absolutely. Is this the correct way you should be structuring your code? Absolutely not. The problem with this is that this is untestable. Okay, this is untestable. And what we mean by this is untestable is that, how can I test to make sure that these routes are working correctly with, if I wanted to test it out with like various types of inputs. How can I test that? Okay. Especially if I want to test it in an environment that's not connected to the internet, right? What if we have no way to connect to the database? We're just trying to see is if our code in here that does a lot of like the validation is working, and so forth. This is terrible. The other thing that makes this terrible is the fact that this uh, this route knows, here's the important part. This route knows that we're using MySQL. That's incredibly dangerous, right? Our route here knows that we're using MySQL. So what happens in the future if you decide to move away from SQL and move over to something like MongoDB, which is what we're going to be doing like next week if Corbin is available. So what happens if we want to move over to MongoDB? Well, let's say we had, 20 different routes and we had certain commands to grab data in a bunch of different places and they're all MySQL. It's it's going to cause such a big headache to go in and gut it, right? And do a replacement. Um, and then even after you do the replacements, you're gonna have to test because there's no way to ensure that you didn't cause an unforeseen bug, unexpectedly, right? Some logical error. So what we need to do is we need to have a way to use these services in an abstract way. Now, that was kind of like the whole point behind creating a service, this user service. See how we have a service now, right here? That was essentially the entire point of this, okay? We have a service which gives us some kind of functionality. Now, this service is supposed to act as a, I guess you can call it like a proxy between our request and the data layers. So we're going to feed it data in one shape. This service will take your data, okay, and it knows the shape, right? We define the shapes of the data right here. So it knows the shapes ahead of time, okay? So it's not dumb. It knows the shapes of the data. However, even though we're describing it as a JSON object, it's possible that the data layer in which you're going to communicate on may not accept JSON. It needs you to format the data in a way that it can understand the data, right? Because you cannot just pipe through, JSON data, for example, just directly. Maybe it needs it in an XML format. So it's going to be the job of the service layer to take your data, transform it if it has to, and then communicate with the data layer. Now the data layer can have different ways of communication. For example, if you're using MySQL and if you want to look something up, you use the select statement, right, to find some data. If you're using MongoDB, you don't connect to it like that. You do it in a whole different way, right? So each data layer has a different interface. So by abstracting away the data layers from the consumers, for example, this route is going to try to consume some data in order to forward it to whoever's requesting it. It's going to be the job of the service layer right here, this service, to take the data, transform if it has to, figure out how to communicate with the data layer, and then the data layer is going to give data back to the service. And it's possible that this data may not be in the correct format that you were expecting. So it's going to be the service's job to then retransform that data that it got back as a response and then send it back to you in a format that has been agreed upon, right? So if like, let's say you were dealing with some kind of data layer that only gave you data in XML format. Well, this service layer is saying, hey, we're going to communicate using, JSON. Well, I cannot give you the XML object because you don't know how to communicate using XML. You only know how to communicate with JSON. So it's going to be the job of the service to then take that XML data and then transform it into JSON and then feed it back to you. So there's some business logic that has to be done there. So that's kind of like the job of the service. The service is like front facing between you and the data layer. So that's why we had to build a service. Again, you can consider this as over engineering, but I'm trying to show you what's going to be done if you were to get a job and you're working, let's say, in back-end development. You're going to see services, data layers, producers and consumers. You're going to see all this kind of stuff. And so I'm kind of trying to show you a little bit of like what all this stuff means. So, when you do get a job doing this kind of stuff, you're going to look at it and be like, oh, I remember this. I know exactly what you guys are talking about, right? So I'll give you a leg up, in the interview and whatnot. So notice that here we have this service, users service, which gives us some CRUD operations. So it allows us to create data, allows us to delete data, update data, get data, and then get more data. But there's no there's no specifics here, right? The service layer in this case is an abstract service layer, it has no specifics. But then we created a service layer that extended the user service, this abstract layer. And then in here, in this service layer, the MySQL user service, here we were more concrete, we were more specific. It's like, okay, the user service is going to communicate to a data layer that happens to be MySQL. And that's all we've done. So the create user goes in and tries to create a user given, this input data. The output data is, MySQL based. Now notice here that when we fed the data into this data layer, into this insert, I didn't feed it JSON data. I had to format it using, this, right? What we're seeing right here. Does this look like JSON to you? Absolutely not. So this data layer does not know how to communicate using JSON. So then it's the service's job to then take the data that we gave it in the format, the shape, which was JSON, and then transform it in a way that the data layer understands what the heck you're talking about. And that's really all that's all really what a service layer does. That's its only job. Takes data in, transform it if it has to, sends it over to the data layer makes a response. The service then transforms that response and then sends it back to you in a way that you understand. That's really it. That's really it. So the service layer does all this stuff for us, okay? Again, you could absolutely do everything that I just said inside of here. The problem is that you have this strong dependency and you have tight coupling. You don't want to do that. You want to decouple your code to make it easier to replace. Okay? That's what we want to do. And so we have this thing called, services. That's what we're talking about. Here we have services. Okay, so how can we abstract this away? Because right now we're talking about MySQL instead of a route, and I told you that this is not the correct way of doing it. So how can we abstract this away? Well, we can do that in the form of something called a service locator. So now we have a concept of a service locator. So what is a service locator? A service locator is exactly what this object's name means. It helps you locate a service. That's it. That's all it does. It doesn't do any more than it doesn't do anything other than that. It just helps you find a service. That's it. So let's create this class service locator. Okay, and it has just a few very simple methods on it. It's not that complicated. It's almost criminal how simple this pattern is. So again, first we're going to need a constructor. So there's our constructor. Okay. This constructor is going to take some services. So this dot, we have a thing called services, and it's going to be a complex object. It's going to be an object here. So what is the type of this service? Okay. Well, the type of this service is, actually, you know what? We'll leave this out for now. We'll leave the typing away. Just know that the service is going to be a JavaScript object. Now, let's talk about how the shape of this is going to work. Okay. And hopefully you are able to understand this next part, because you can actually use this to your advantage when you're doing some algorithmic problems. I find that especially if you're doing it in JavaScript, I find that using the power of JavaScript objects, especially when you have IDs throwing around, is incredibly powerful. It's one of the things that I love about JavaScript. Okay, so the service locator, so the service locator is a pattern where it's going to contain pointers to services. And the way that you can find a service is through some kind of ID system. So the IDs must be unique. So if you have two services called tuna, it has no way to distinguish between the two, right? So all the IDs for your service locator have to be unique. So the service locator is just going to create and maintain a table. That's it. So you can think of this as the ID or the name. And then over here, we're going to have, in C# or whatever, or in C++, we just call this a pointer. It's just a pointer or a reference. We can just call this a reference, okay? And all it's going to do is this side is just going to be the actual service object. So the actual service, okay? I need a pen. So for example, in our case, we can have an ID called, users service. Okay, I can't write. Okay, and it's going to be a string, so I'm going to put these in quotes. It's going to just be user service. It's an ID. It's going to be a string, and then the actual service object could be anything, as long as it's a user service. For example, it can be the MySQL user service, blah, blah, blah. And it's going to be the actual object. So all it's going to do is it's just going to point to it. And so then later on in your code, for example, in your routes, when you need to do something with a user service, like look somebody up or authenticate somebody, all you have to do is say, hey, user service. So, service locator. Can you find me? So, oops. So we'll do a dot, and then the method we're going to create is called find. And then we're just going to pass the ID. So we're just going to say users service, for example. Be like, yo, can you find me this? And then this is going to return a service, the object, if it can find it. And that's it. That's it. That's a service locator. This is called a this is a service locator pattern. So this itself is a pattern. When you're dealing with services, it's a pattern. Okay, this is part of the IOC topics, which are pretty advanced. This is called inversion of control. And we're going to come full circle to another topic that's called dependency injection. Okay. So let's start with this very easy one, the service locator. So like I said, I already kind of preluded, we need to have a way to find a service. So let's find a service. Find service. That was easy. So we'll call this the service ID. Okay, service ID. So let's add some parameters here. So what's the parameter here? Service ID is going to be a type of string. Now we want to return something. So this thing is going to return. So returns what? So, we could return base service if ideally all we're dealing is with services. You could just say, okay, we're going to return a base service. Okay. That's it. So all we're going to do is we're going to say return this dot services, and service ID is just a string, and again, this is just a JavaScript object. So the keys, remember I told you the service locator is just going to keep track of a table. So this dot services, and we're going to look up via the service ID. So this is going to return a base service, or it's going to return undefined, because if it can't find it, it's going to return you undefined. So you're either going to get a base service, which is the service that you're looking for, or you're going to get undefined. That's it. So it says find service. We need to wait to set the services. So we're just going to say set service. So we're going to say service ID and then the service. Okay. And so we're going to then tag this with the service ID is going to be a type of string, and the service is going to be a type of base service. So as long as the object inherits from base service, we're good to go. So what are we going to do here? This dot services at service ID, oops, is equal to the service. We're going to keep track of it. What a simple pattern. That's it. That's the pattern. Find service. We can even call this something else. If we don't want to call it find service, we can call it get service. Since we're doing a set, we can also do a get, right? Get service, set service. Okay, and that's it. We can do module.exports. Now, ideally, you will only ever have one service locator, right? So we're going to create a somewhat of a singleton. So I'm not going to use a singleton pattern here because it just so happens that module.exports keeps a cache of everything that gets exported out. So by me understanding that exports actually caches it for the lifetime of the application, I can exploit that by saying return new service locator. I'm going to return an actual object back. And by me doing this, export is going to cache this. And so now this module is itself a singleton. So all modules are basically singletons by default. Okay, because ideally you would export a class which gets cached, and then you create instances of them. In this case, we're just going to return an object. And you don't ever make a clone of an object, like there would be no reason in this case to do that. So I have effectively here created a singleton by just returning an object itself. So how can we now leverage this? Okay, well, in index.js, after we create our database here, so after we have set it up here, we now need to do something. We need to do something. So the thing that we need to do is basically what's in here. We need to create a connection because this MySQL user service has a dependency of this MySQL connection. There's a dependency here. So how can we address this? Well, if we're able to ensure that our database exists, right, and we've set it all up, okay, all we then have to do now is create a connection. Okay, so we're essentially going to move this code in here. Okay, now we're going to remove this code. Okay, cool. So now we have a connection. So who needs the connection? Well, this MySQL service needs the connection. Okay, so let's do that. So we can say const, call this users service is equal to new MySQL user service. Now you'll notice that the constructor here takes a connection. This is the MySQL connection. There's a dependency there. So we're going to give the service this connection. Okay, and that's it. That's all we got to do. Okay, so now that we have that, we have our service here. It exists. It's right here. So now that we've created it and we've initialized it, we've injected the dependency, this connection, we just need to set it in the service. So now we say service locator, and by doing that, at the very top, we're bringing in that service locator. We're requiring it under services, service locator. If we hover over here, I'm just not going to tell you. But here, if we do service locator dot, we get service, the services object, and set service. So we're going to update this. We need this to be private. So go like this, type this as @private. Okay, we don't want to leak that, encapsulate it, so we do dot. You only get these two methods, get service and set service. Since we're in the setup phase, obviously you're not going to get anything. That doesn't make any sense. We're creating the service, so now we need to set the service. So we're going to say set service, Now here's an interesting question. What should be the ID? Well, the ID should be the abstract, quote unquote, the abstract class. That is users service dot name. So in JavaScript, you can actually get the name of the function or object by saying dot name. So there you go. So this name is just going to be a string. So this exists on function, so returns the name of the function. Function names are read-only and cannot be changed. Cool. So now we have this class's name. So user service dot name, and then we're going to pass in the service, which is user service, which we created, right? Because remember, MySQL service, this MySQL user service extends user service, and the user service extends base service, and the service locator only knows how to deal with base services. Okay, you could call this a service, but I just call it base service to make it explicit that, you know, base service doesn't really do much. It just has one function, initialize, and that's it. Okay, so it's important to note that the base service needs to be initialized. So we need to also say await user service dot init. So we need to await this. Now this init is going to return a promise, so we can just await it. Again, you should do this because you have no idea if this MySQL user service needs a moment to initialize something, right? We have no idea. Now in our case, we haven't implemented an initializer, so we're just going to assume for now that this doesn't do anything, but you should always call init if it's required. So just call init. Okay, and later on, if we need to put some logic in there, we can put it in there and we already know, hey, init's gonna get called. So this is just, you call this once. And because since we're controlling the creation of this object, of this service here, we know it's only ever going to get called once because this database setup will never get called again. Okay, so we created our connection. We created our service. We fed it the dependency. We're awaiting its initialization. We're then setting it to our set service. Okay, so we could even do something like this. We can log console.log users service initialized. Okay, and done. We're going to say users service initialized because we have that, and then database setup complete. So Victoria is asking, could we put await in front of the new keyword instead? No, because this new is just going to return a MySQL user service, right? That's all it's going to do. It's just going to return an object. This is a method that's on that object, so you have to await the actual method. You can't await the actual object. It just doesn't make any sense. Okay. So now that we've awaited the method here to initialize, we then set the service. Now again, we're going to do this for every single service that we have. And every single, you know, in this case, we're going to break up the services into the different data things that we can do. So that's about it, right? So each service, we have a user service, which is going to interact with the tables for users. But we can also create, and we're going to create another one called post service, which is going to be a service that can interact with the post table. So it knows how to, you know, add a post, remove a post, blah, 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 blah. And maybe even that service has a dependency on the user service. And so you can see why you would want to use a service locator, because you want to keep everything abstract. So in the future, we can drop in a MongoDB service and all the code that we've written, it wouldn't matter. So now that we've done this, we've updated to a service locator pattern. How can we now leverage this? Well, instead of creating the service here, we go like this. We say const users service is equal to service locator dot find, or get user service, or get user service dot name. We're going to get it. Now here, because the return type is just this base service, because get service either is going to return, let's see over here. Yeah, so get service is either going to return a base service or undefined or whatever. we can actually type this to be like, hey, oops, at type. This user service is in fact going to be a type of user's service. So now what's really cool is we can say user service dot, and now we have our methods here, right? How cool is that? So we have our methods now. And that's it. Now notice how abstract this is. User service, what type of service is it? I don't know. I just know it's a user service. What's the data layer? I don't know. Why should this route care if the data it's going to grab is from MySQL or MongoDB or Postgres or some other kind of database? Who cares? Why should this route care? It shouldn't. It just knows, hey, I need to interact with some data. Okay, what service are you going to use? Oh, I'm going to use the user service. Okay, cool. Now what do you want to do? I want to create a user and then here's some data. Okay, cool. And that's it. And that's all we do. There's nothing more complicated than that. Look how simple this is. It's super abstract. However, even though all we're just saying is, hey, just create a user. Under MySQL, the actual concrete implementation, look what it's doing. It's going out and it's doing some MySQL stuff. But in the future, we can replace this with MongoDB if we wanted to, or some other, whatever. We can store things into a file or whatever. We can do whatever we want. And this route, the code here, even if we change the data layer, would never know because it has no idea where the data is coming from. All it knows is that it's interacting with this service. Create a user, what does that even mean, right? Is it going to be stored in MySQL or Mongo? Who cares? That's not this route's responsibility. The route is just trying to do stuff. Okay? And it's going to be the service's job to communicate with the data layers to either store data or retrieve data, and it's going to have all of the business logic in order to accomplish that goal. Does that make sense, everybody? Are we understanding how service locators are supposed to work? And what services are doing, how they're front facing, they're facing between the person doing the requesting, the classes doing requests, and then the actual data layers. Okay? Does that make sense, everybody? Are we good? All right. So the next thing I want to talk about is um, so the next thing I want to talk about is like how we can use routes. We want to use routes. Or actually, you know what? Let's finish up the MySQL before we talk about routes. So here I'm going to save this. Okay. And look how abstract this is. Look how beautiful this is, right? We could move all of this other stuff here, all this setup. We could move that to a different file. But our core logic is actually just living in here. And we can even make this even simpler by moving things around, okay? Look how simple this is now. It's very simplistic. It's very easy to look at and maintain and also to figure out what the hell this code is trying to do. Look how beautiful this is. I think this is beautiful. It's very simple and it works. It's very elegant. This is nice code. Again, this is not perfect code. We're going to try and make it better, but this is a pretty good start. Our stuff is starting to look a lot better. This is not amateurish in any way. We're starting to get to like intermediate to advanced level here. This is pretty good. This is pretty good. Okay. Okay. So let's finish up the MySQL, like how we create a user. Now, there are some scenarios that we need to address for the data here. And I'm going to address these by actually causing errors. Okay, I'm going to cause some errors. So I'm going to delete all this stuff here. So So the way this works, this promise here, okay, is that we're just going to try and create a user, right? That's the command. We're going to just try and create a user. So that's what this promise does. So all the logic is in here. Remember, when we await a promise, it actually executes this, okay? It puts it in a queue and all kinds of stuff happens. And then it only gets, queued out if it gets resolved or rejected. It gets resolved once you invoke resolve, right? So everything went well. We say resolve is a success. We then call reject if something happens, some kind of error, okay? Any number of things that can happen here. Okay, cool. So what are we supposed to do here? So when we create a user, remember, we're going to pass in this user's DTL, right? And so to remember, if we hover over here, a user DTL is a username, the first name, the last name, the email, and the password, okay? A user is a user ID, a username, first name, last name, and email. So remember I said that a user DTL, which is called a data transfer object, is supposed to usually be a subset of the object you're actually trying to talk about, right? We call this a plain old object, POL, whatever, plain old object. So once we insert it, if everything went well, right? If everything went well, then we're supposed to return a user. Right now, once we insert it, we are not returning anything. So how do we return the user? Well, we need to capture it, right? We need to capture it. So what I'm going to do is I'm going to remove this. Well, we'll do it this way. So we're going to say const create user command, const, and then we're going to say, well, actually we can do this. We can do it this way. We need to now get the user, right? We need to get the user. Well, we'll do it here. Const get user command is equal to new promise resolve reject. Now, how are we going to get the user? Well, we need to look them up, right? We need to look them up. So how do we do that? This dot connection. We're gonna initiate a query. We do SQL. I'm gonna close this up so we can see here. And so I'm going to show you how we can use something called prepared statements. Okay. And then we're going to update this because this has a security vulnerability, right? We are opening ourselves up to something called SQL injection. So I'm going to leave that here as a way to, so you guys know like, hey, that's bad. And we're going to fix it here. So here we're just going to say select. We can say everything for now from users where, and then say user ID, user underscore ID equals question mark, semicolon. Okay, so that's our statement. Select everything from users where users underscore ID equals question mark. So what the heck is a question mark? Well, what's really cool is that SQL will create a prepared statement. Okay, so it's not going to execute this command. It just prepares it. When it goes to execute, it's going to inject itself the question marks. The cool thing is that it's not going to run it. That's the beautiful thing. So if there are any kind of like SQL injection tactics like backticks and whatnot in order to try and like do stuff, it ain't gonna work. So it prevents those kinds of things from happening because it's going to handle it, create something called a prepared statement. It has to deal with how things are executed in the SQL engine, right? So in this case, when we inject it ourselves, this is just doing anything, right? There's no way of telling what the heck's going to happen. Like, what is username? I could put a backtick on it with a semicolon, and then I can start a whole new query like drop database users, for example, and it will destroy my database or drop table users, or I can say, you know, all kinds of other nasty stuff. I can actually inject SQL commands if I do it this way. And if we have time, I'll show you some examples of that. Basically, how hackers are able to get into somebody's database. I can actually show you how that works. So we're going to use a prepared statement. We use values. And values is going to inject the code without actually executing it as a command. So it's going to treat the entire thing as a string, not a command, not separate commands. It just treats everything as a single string. So values can be used in a couple ways. One, if you only have one question mark, you can just put the value directly. For example, we not the user ID. We don't want to look for it there. We want to look for it where the email, or we can say username, whichever one. Either one is unique, where username equals. So we're going to look it up by username because we only have the username. We don't have the user ID yet. So we can say select everything from users where username equals, and we can pass it from the user DTO dot username because we have that information. Okay. If this is the case, if we only have one question mark in here, then boom, this is just going to be in there. If you had more than one question mark, then all you have to do is feed this in array. Whoops. Feed it in array like that. If you had more than one. So if you only have one, you could do like this, but you're typing some extra stuff, right? But it's not needed. We'll do it this way just to prove that it works like this. But you don't need to feed it as an array if you only have one question mark in there. That's the cool thing about values. It takes in either just a single parameter, which will get injected into that question mark, or if you have more than one, you can use an array. I'm just going to keep it as an array just to show that it works. But yeah, okay. So remember, the next the next part here in our connection after we do the query. So this is a query object. The next thing is we need to feed it the callback. So this is the results and then the fields. So this is our callback. Okay. So if there is an error, so if the error object exists, we just say return, reject, and just pass the error object in there. Else, we get a result. So I'm going to console.log the results so we can see it. And then in here, I'm just going to say resolve, and then the results. Okay. Now, I can tell you right now that whenever you do a select statement, okay, you're always going to get an array of records, because that's, you could get more than one. Now, because we have a where statement, you know, in our case, the user name should be unique, so you should only get one record. But when you do a select statement, MySQL has no idea ahead of time if you're just going to get one record or many records, right? Because you could say where something is greater than 100, like salary is greater than 100. There could be more than one person that has a salary greater than 100, right? So, you know, this results is going to be an array. Now, I hate the fact that here doesn't let you know, but at the same time, it's kind of hard to tell because the select statement is a string. So, yeah, but the results will be an array. And so hopefully you can just say results at 0 because you should only have one user with that username, right? You shouldn't have more than one. But just to drive the point, I'm going to log it, and I'm just going to put the entire results in there, and then I'm going to come back and fix it. Okay, so once we create the user, if everything went well, then we need to now capture the new user by saying const new user is equal to await and then get user command. Now, this new user, as you can see, it's just type of any because, again, we're not using TypeScript, so it's very, very hard to figure out what the type is. But when you say resolve, whatever you pass in here is what actually gets returned by the promise. See, this right here says any because we haven't typed anything. But this is going to be our new users. Now, remember, we have an asynchronous function, so this is a promise. So here we can just, once we have this, we can just say return new. I don't know why I put new users, new user. Now remember, this new user is going to be this results. Now the problem, like I told you, this result is going to be a what? It's going to be an array, right? It's going to be an array. So obviously this is wrong, but I want you to see it, okay? So here, when we create a user, remember, when we create a user, we're supposed to get back a user. So we're going to say const user equals. Now here's the problem. Create user is a what? Returns what? A promise. So we have to await it because it's going to take some time. So what we need to do is we need to mark this route as asynchronous. So now what we can do is we can, because right now if I hover over user, user is a type of promise. It's not the actual user itself. It's a promise, right? So what we can do now is we can await, because our route is now asynchronous. We can now await the creation of the user because it can take some time. If we hover over this, if everything went well, we should just get a user back now. See, now user is a type of user. So now what we can do is we can say, okay, result.json, let's send back the user. And remember, when you create a user, we can actually set the status code. So status of 201. 201 means creation. A resource was created successfully. So let me format this so it looks all nice. There you go. Look how simple this is. Look how simple. It's so simple, guys. Look, we have a service. We got the service. We have no idea what the data layer is. It's just a user service. So it could be using Mongo or MySQL. I don't know. We then do a request. Hey, can we create a user? And here's some data, by the way. We then await it. It's going to take some time to go out to the database and do whatever things need to be done. All we know is that, hey, we're expecting a user back. Okay, we got the user, hopefully, right? If everything went well. And then we're just going to respond back with a 201, right? Again, we haven't done any checking to see if this succeeded. So this could crash. This could crash because remember, every time you await, there's a chance that something can get rejected every time you're dealing with promises. So remember, it's still a possibility that something gets rejected, right? The creation of the user, you pass in all the correct values, but a user already exists with that username. So this could crash. And so we need to return back proper codes. But for now, we're going to be naive and just try it out. All right, everybody. Fingers crossed. So here I'm just going to run it now. Now I am already running. Oh, you can't see it. I'm already running examp. So if I open up my examp thing, I am already running examp. Okay, so it's already running. So now I'm just going to run this. Whoops. And fingers crossed. Okay, nothing exploded. Good. It says user service initialized, database setup complete, listening on port 5050. So awesome. So simple. All right, Postman. Let's open up Postman. Let's try do a request here. Okay, let me make this a little smaller. Okay. So on Wednesday, I created this user. So I should expect that if I try to create the same user, it should explode. But before we do that, let's make it legit, right? So let's put polymorphic 2, mail 2, because email has to be unique too, right? So we'll do mail2@mail.com, and everything else can be the same because first name, last name, and passwords are not unique, but usernames and emails should be unique. So if everything went well, right, I should hit send. I should get a 201 response, and in the response, I should get some JSON back, which is the representation of a new user. So let's see if it works. Beautiful. I got this, but I don't see my data here. Get user command is not function. Okay, so, oh, okay. I messed something up here. Damn it. Did I call it as a function? Whoops. It's not a function. It's a variable. My bad. Nobody caught me. Okay, let's try this again. So polymorphic 3. And then mail3 at mail.com. Let's hit send. Good. So now you see we have a 201 created, which is good. We then got the data. Now you'll notice that it's a what? It's an array, right? It's an array because I told you when you do a select statement, MySQL has no idea if you're going to get one or more than one record back. Heck, you could get 0, right? You could get 0. That's a possibility as well. So that's why I fed the, if we go back up here, when we got the result, you see how I'm printing it out? So this is the result. It's called a row data packet. So it's an array of row data packets. So we're in here we did the select statement and we got everything because we said everything. Again, isn't that terrible? This is terrible because look, we returning the password. That's not good. The password needs to be what? It needs to be like kept a secret, right? So we're leaking data because we just said, you know, select everything, which is not what we want to do. We don't want to be selecting everything. Okay. And then on top of that, we're just blindly returning the results back. The results, because it's coming from a select, will always be an array. So the array can be no records met your criteria. So it's not going to error out. You just didn't find anything. For example, if you had a table of employees and you say, give me all the employees with a salary greater than $1 billion, if you put that, instead of like, 100,000, you accidentally put 1 billion. SQL doesn't know that that's a mistake. It's just trying to find those users, those records, meeting your condition, and it just so happens to have not found anything. So you get an empty array. So that's a valid result. It just didn't find it because you put a condition and didn't find it. That's totally valid. In our case, it would make absolutely no sense that if we created a user and then we tried to find the exact same user with the username that just got created, that we didn't find it. That would make absolutely no sense. So we say if results.length is equal to 0, we can say here, the heck? How is this possible? Right? We need to error out. This should never happen. Now, the reason why I say that this should never happen is look at the way we set things up. We try to create a user, and if for some reason creating the user fails, this line of code right here, which is to get the user, should never execute because this should throw if something happens. And it'll skip over this line and go straight into the catch. Do you see? So this should never happen. However, it's possible that somebody does not put it in a try catch or something, right? There's a million different things that can go wrong here that can cause this scenario to actually occur. So we need to also be, preemptive in all these possible scenarios and then check. Okay, if results.length is equal to 0, this should never happen. So I'm going to say reject. So I'm going to say return reject and then say something like new error unexpected result user should exist but does not. There we go. That's a pretty good thing. Unexpected result user should exist but does not. Okay, now if that's the case, we should have at least one user, and that's the only user we care about. So now it's safe to do this. There's also a possibility that results could be undefined. So we should say something like results and to make sure that results is not identified. So we need to make sure that the results object actually exists and that the length of it, well, we should do something like this. If the results doesn't exist, or to say, because what if it does exist, right? So if it does exist, or the results.length is 0, then we are in some uncharted territory, right? This scenario should not happen, but in the off chance that it does happen, we are prepared. So the scenario is that the results doesn't exist, or it exists, but the length of it is 0. So if that's the case, it's like unexpected result, user should exist, but does not. Okay. At this point, we know that the results exist, so it's not undefined, and it's an array with at least one record in here. And by our logic, we should only get one user back, one record, because the username is a unique index. So we should only get one. Okay. So how does that change things? Well, if we kill this, let's start it up again. Go back over here. Notice that we have a 201 and we got back an array. Okay. So now let's change this to, let me blow this up a little bit. Polymorphic 4. So we got a new username and a new email. Okay, hit send. So we get the 201 created, but now we just get the actual user, just the one user. No array, it's just the user. Beautiful. Okay, beautiful. So now this API is working great. So now we can create users. But what happens if somebody tries to be cheeky, right? It's like, okay, I'm going to hit send again, right? This user already exists. What the heck's going to happen now? All right, now it exploded, okay? We still get this 201. That doesn't make any sense. Why are you getting a 201? And then we have this error over here. Error dupe entry, duplicate entry polymorphic 4 for key username. It already exists, right? When we tried to insert it, it errored out. Okay, so why didn't this thing explode? Because it's still running. That's because here we caught it. See, we caught it over here. So we caught the error, right? We caught the error here under create user. We caught the error here, okay? But now that we caught it, we need to do something about it, right? So let's kill this, okay? Let's kill that. And let's try to figure out how we can go about this. So let's try to remove this try catch. I'm gonna do it like this. Okay. So we're going to await this. This could possibly throw. Now we're inside of this async, right? So we're inside of this async. So now it's going to be the job of this route to catch it. So, okay, let's see what happens now. We're going to run this. We're going to run the exact same command. Okay, we're not going to do anything. We're going to see what happens. Okay. So now we have this issue here where now it's stuck. Now the reason why it's stuck is because it crashed here. And so because it crashed here, what happens? This, the response here never ends. So the connection is now hung. So now we have a problem here. So we're going to hit cancel here. Okay. So now we have this error here, right? So this error again is coming from the unhandled promise rejection warning, error dupe entry duplicate blah blah blah. But notice how it's saying it's unhandled. So how can we handle this? Whenever you're going to do something dangerous, like create a user, for example, we need to wrap it in a try catch. This is dangerous territory we're in. Okay, we're gonna try it. Now we're gonna catch it. Okay. Now here, all I'm going to say is console.log an error occurred. Okay. I'm going to say response. Whoops. Don't want to do that. Response dot status. And for now, I'm just going to say a 500, an internal server error occurred. I don't know, because we have no idea. Okay. And then we're going to say dot end. Okay. We're not going to return any data. We're just going to say dot end. Because right now, we don't have any way to handle any of these unforeseen errors. Okay, so that's all I'm going to do. I'm going to wrap this around a try catch because this is a dangerous operation. There's no guarantee that this is going to work, right? This is a dangerous operation because remember, it's returning a promise. It can get rejected. Therefore, it is a dangerous operation. We're going to run this again. We're going to run the scenario again. Hit send. Now, notice now, we say an error occurred, and then we're getting this 500 internal error. So we were able to isolate this error that could possibly doom our server. So we caught it. And we're just right now we're just returning this internal server error. Okay, how much time do I have left? Shit. All right, I know it's Friday. Are you guys cool going to 8 p.m.? If not, let me know. It's totally fine. I just have some more stuff I need to talk about. Back-end development is quite extensive. I want to make sure I cover all my bases here. Hopefully you guys are enjoying it. You guys are learning. So let me know if you guys are okay going to 8. If not, you know, if at least one person stays, I'll keep going, and then, you know, anybody else that's busy can take off and then can come back and pick up where they left off. That's also a possibility. So let me know if you guys are cool with going to 8 o'clock. I am. Keep up so far. Probably fine. Okay. We'll just keep going. Let me know if you guys have any questions. Let me know if you guys are learning anything. Please let me know. If you guys have questions, please tell me. Is this digestible? Am I going too fast? Am I going too slow? Backend to me is really fun. It's really fun. The only problem with backend development is it's like kind of hard to show somebody your progress because it's kind of hard to just be like, yeah, here's some code. Let me show you some code. It's like, okay. Versus like front end, you can actually show them, like visually show them something. But I really do enjoy backend development. So hopefully you guys are enjoying hearing me talk about this stuff. So, okay. Anyways, okay, so let's keep going. So, I'm gonna have to rewatch all this later. Is the code gonna be posted too? Yes, I will post the code. Please, somebody remind me to post the code. I have terrible memory. Okay, so we have this situation now, right? Where errors are occurring based off certain requests, like this create user and stuff. Something can explode, right? Now, let's see what the error looks like. So console.log e. Okay, so I'm going to kill this. Node index.js. I'm going to run this again. It's going to explode. And here's the error we're logging. Okay, so an error occurred, and this is the error that occurred. Okay, duplicate entry, polymorphic for key username. Cool. Okay, so Now notice that what we're seeing here, notice how here's like, oh, SQL index, SQL stay, SQL message, error number, the code, yada, yada, yada. This is all very, very specific to MySQL. If we had the same issue with, let's say, MongoDB, the error codes would be completely different. So what I'm trying to get at is that the service should not only handle the transformation of the input data and the output data, so we have a unified way of communicating with data, but we also need to have a unification, okay, between possible error handling, right? Error codes. Again, you could say this is over engineering, but I think that it's totally valid. So I'm gonna create a folder here. I'll just create a file. Let's just call these errors.js. So this is going to be my log. I'm gonna store data in here. Okay, that has to do with possible errors. Okay, some error codes that we can probably come across from our services. So let's do this. So we're gonna create a const. I'm gonna do these error codes. Okay. So what are some possible errors that we could come across? Well, we have some error codes that could come from, let's say, a database. So we have some database errors. Now, remember, this error code is just going to be an object. An object where the key is going to be the context of the errors, and the values are going to be objects where those keys are going to be the actual errors. So in a database context for errors, we could have what? Well, the first one that we're running into is a duplicate. Now, this same error, remember, we're trying to abstract here. Always, always, always think abstractly. Okay, never put anything concrete. Okay, don't do that. Is it possible that in multiple different data layers, whatever they are, is it possible that you can run into a situation where you try to insert a record or insert a resource or whatever, some data, where it could already exist and that can error out? Is it not safe to say that that is a possible error? And I think that yes, it is. You could have an error, whether it's in Mongo or MySQL or Oracle or SQL Server for Microsoft or whatever, where you try to insert a brand new record, but that thing already exists. And so that's going to throw an error. How does it throw that error? That's going to be unique for every situation. What the error code looks like is going to be different. For example, here in MySQL, the error number is 1062. In Oracle, it could be 001. In Postgres, it could be 22222. I really don't know, right? It's going to depend on those specific data layers. So what we need to do is find the intersection of the possible errors and their contexts and try and find an abstract way in order to be able to encompass all these possible errors. So the first one that we're running into is something called duplicate. So you can assign the numbers here at this point. This is just software architecture, right? At this point, this is just software architecture. So usually you would talk to like a software architect or talking to your backend people, get in a group and be like, what should we call this error? Right? What's the number? So that if we ever see this in a log or one of the users says, hey, I got this error code, and they send you the error code, you know you can look up in your error code table and be like, oh, this is a duplicate. There's an error code for a duplicate. Have you guys ever played like a video game and then like you're doing something and then all of a sudden the game crashes and it says crash with error code, 5521118. You're like, what the hell is this? And then the developers are like, hey, just send us the error code. and you send them the error code, and then they tell you, oh, it's because blah blah blah. You think, wow, these guys are geniuses. Maybe they are, but it's not. It's very stupid easy. It's just trying to like have these error codes have some meaning, so when they do happen, we can kind of gauge and have an idea of where the error is occurring, who's at fault. Is it the user? Is it the developer? What's going on? So having these error codes is a nice way to try and narrow our search for where there could be a fault. Okay, so the first one is pretty easy, duplicate. So I like to split this up into two things. The number, we can give a number. So let's say duplicate is a 1000. I don't know. This is totally, I'm literally pulling this number out of my ass. I don't know. It could be error code 0. I don't know, right? Again, just pulling this out of the air. Okay, so that's going to be the number. And then we're going to have, let's say, the text. What should the text look like? We'll just say it's duplicate. Okay, that's pretty simple. Again, that's it. That's it. That's all it is. Okay, so we have a first error is duplicate. Cool. We're done. Module.exports is equal to error codes. We're going to push this error code out. Okay, so we're done there. So here's the thing now. User service here at this point, remember I kind of hinted that this is a terrible idea, because what we're saying here is that we're guaranteeing that a user is going to come back. But what I'm saying, and what I've kind of already shown you, is that there is no guarantee you're going to get a user back, because what if you gave me faulty data, right? Then at this point, it's just like, well, shit, right? There's no guarantee you're going to get a user back. So what do we do? Well, we cannot guarantee you're going to get a user. So all we can say is you're going to get maybe a user, but you also might get an error. But we're going to control the error. We're going to control it. We're going to fail, but in a controlled manner. Okay. Okay, so then so how do we control these errors then? So in the services, what we can do is we can create something called a and this is coming from, again, this could be done in a multitude of ways. I like doing it this way. We create an object called a result. So result.js. And all this is basically going to be God, this is so much easier to do in TypeScript. So we create a class. I'm gonna see if I can do this in JavaScript. I honestly don't know how this is gonna go. So we have this class called result. Okay, so we're gonna just do a module.exports is equal to result. We're gonna send out the thing here. So this class can contain one of two things. Okay, so we're gonna have a constructor here. You can have either a payload, okay, which is your actual data, or you get an error object. What that error object is going to look like is going to depend heavily on a number of factors, like what type of error, right? Again, I say this is so much easier to do with JavaScript because of generics. But I think I'm gonna have to look this up because I want to make sure I can do this. JavaScript JS doc generics. I won't even know if this is even possible. Okay. Okay, so it has been added to ES6 classes. Okay, but what if you have more than one? Perfect. Okay, so we can do this. Amazing. Okay, so the JS doc to do this, which is cool. I want to, oh God, I love TypeScript. Every time I'm in a situation where I need TypeScript, I just fall in love with it more and more. So we can do something called a template. And here, what I just want to do is do a I payload and then I error. And that, I believe if I'm reading this correctly, should literally be it. So we have a payload, this I payload. Beautiful. Look at that. That's a nice generic. Okay, so we have this result where it's a payload, and we have this error. Now in the constructor here, this payload is going to be a type of I payload. Okay, and then the error is going to be type of I error. Ideally, in an ideal world, these are just interfaces. Okay, these are interfaces or just something. Okay, it doesn't really matter. The error does matter. It should be a type of error. But right now, let's just go with this. So our payload, if we hover over this payload object now, is a type of I payload, which is great. So now I can just do this dot payload is equal to payload, and then this dot error is equal to error. Okay. Now the problem again with JavaScript is if I hover over payload, it's a type of any, because it really has absolutely no idea what the type is. Okay, it's not that smart. So what we need to do is we need to add a types ourselves. So at type, this is a type of I payload. Okay. Okay. Now, oh, not this, not I payloads, I error. Now, a lot of the times what we could do in order to have less less typing, we can just do T. Sometimes you'll see like this, where T is like just a generic, and then we have this one be E, where E is going to be our error. Sometimes you'll see it like this. I didn't want to do this because I didn't want to confuse you. Hopefully this isn't confusing. What templates are is basically we have no idea what the type is going to be ahead of time, right? That's the thing, is we have no idea. All we're trying to say here at this point is that we want to have a container called result that could contain your result, which is the payload, or you can have an error. What the error is going to look like, we have absolutely no idea. That's all we're saying, is we have no idea. But who will know? That's going to be the user's service. So inside of our errors, or let's rename this to error codes. So error underscore codes. So those are error codes. Now let's just spell it all out. Let's not be lazy. Error codes. Okay, there. It's error codes now. We're going to create another. We can't create that though. How do we want to do this? Because these should always be should be interfaces. So how would I do this in TypeScript? How do we want to do this? Okay. So we have this result here. Now the result's going to have a payload and an error. The error, so let's do this also. So we need to create a class for our error. We're going to mark it as I error. So basically saying, hey, this is an interface. The error, we can extend it and make it a little bit more unique for our use case. But let's try to make something where it's like, okay, let's make it a very simple I error, like an error. So let's make a unification for this. So what should the error contain? Well, I think the error an error should contain a message and maybe a code. Okay, so let's type these. So the message I think should be a string, and the code can be this number. Okay, a code can just be a number. Okay. Now we're going to say this dot message is equal to message, and this dot code is equal to code. Now again, we need to retype these because JavaScript's not that smart to figure this out. So we're going to say, hey, this is a string. And then we're going to type the code and be like, hey, this is a number. Oops. There we go. Okay, and that's my error. Cool. So now that I know that, so we have this template, basically this template T, we can actually remove the E now and just be like, hey, this is going to be a type of I error. Beautiful. So now we have something that this error can actually be. The thing is that the payload, we should not restrict what the payload could be. The payload should be anything. It could be a number, it can be a string, it can be an object, it can be something else. I don't know. The error, though, I feel like we need to make like something a bit more concrete. Like we should follow this interface where an error should have a message and a code. But if you want to be a little bit, you know, something needs to be a little bit different, then yeah, you can do something different there as well. So here in the exports, we need to export the result and this I error class in case we want to create an error that's a little bit more, you know, a little bit more, you know, a little bit more specific. So we have this ability now. So now we have a way to capture a result, which is going to have our payload and an error, which is a type of I error. So we're guaranteed to always have a message and a code. And if we expand on it, we can have even more errors, you know, more data if we wanted to. Cool. So what are we going to do now? We need to replace this guarantee because this promise right now is returning a, basically what this looks like to me is you're guaranteed to have a user. Well, that's not the case. There's no guarantee you're going to get a user. So I'm going to bring in this result object or class. So we're going to bring in result dot, and all I want is the result, because in here I'm not going to create a very specific error. I just want the result. So what's cool about the result is this result is a generic. So what's the payload that we're going to get? It's a user. See, this result takes in a we have this user right here. Okay. I think I'm mixing something up here because I don't think I can create a type there. Okay, whatever. We'll address it later. Okay. So this result, we have this this result can is a generic type, and the payload is going to just so happen to be a user. Now, let's update the promise on the MySQL, and let's see what that's actually going to do now. So in here, instead of returning a promise like this, we're going to say, okay, what we're actually saying is we're actually going to return a result. Okay, a result. Okay, it doesn't like that. Okay. So what we're actually going to do is we're going to return a result, and there's a result using destructuring. And what this result going to contain is a user. Okay. There it is. It's a type of user. That's it. So what does this mean? So is this thing running? Yes. Kill that. So what the heck does this mean now? Well, this means that if something fails in here, we need to capture it in here. Okay. So what's that going to look like? Well, we know the thing that's going to fail probably is going to be all of this, right? So let's grab all this, Now we're going to bring back that try catch block. We're going to try and do something, and then we're going to catch E. Whoops. Okay. We can no longer return a new user like this. This is no longer going to work. This is not going to work. Now, this get user command, let's type this. Let's type this if we can. Can we type this at type? I'm going to type this as a type of promise that's going to return a user. Get user command, that's what this does. So now if we hover over here, this is a promise that returns a user. Beautiful. So now if we hover over new user, we should get a user. Amazing. Very good. So we typed it out. So this get user command should be a promise that returns a user. Amazing. Okay. So what does this all mean? What was the whole point of having the results? Well, it's a way for us to unify the errors. Okay. So what can we do now? Well, if everything goes well, we're going to say something like this. Return new result. The type here is going to type of user. Okay. In the constructor, we're going to pass in this new user. And then for the error, we're just going to pass in undefined. Okay. And so that's all we have. That's all we're doing. In fact, I think if I just do new user in here, and then just type for this error, just type in undefined, right? So there's going to be no there's going to be no error. Okay. So we have this now. Amazing. Because in the promise here, we're saying, hey, we're going to return a result that can contain a user. And that's what we're doing here. So if you hover over the result now, you notice that the type now is user service.user. The payload, you'll notice, is a user service.user. And the error is just this I error, which just happens to be undefined. Okay, that's cool. But what if we have an error? Well, here's the thing. If we hover over this error, we just get this any. That's a problem. Right? That's a problem. We need to type this error. So how can I type it? Well, I can just do it in here. So I want to say that this is at type. Can I do it in here? I don't think I can. I feel like I've done this before. Okay. So here we have this error object. See, this is this MySQL error. So let's log this out. Console.log e. Okay, let's log this out again. So let's run this. In fact, yeah. So this should crash either way. So we're good to go. This is gonna crash. So let's bring out Postman. Let's run this again. Let's look at the crash. Okay, so we have this code. We have this error number. So it's a 1062. Okay, cool. So what I can actually do now is I can say if e dot error num. Actually, instead of doing this, what we can do is a switch statement. Switch e dot error number case 1062. We're going to do something. Okay, we're going to do something. So I'm going to, all I'm going to do now is I'm going to start logging the code and the error number from this error. All right, so if we have a 1062, what does this mean? It means that we insert something with a duplicate entry. Duplicate entry. That's what this error is telling us. So what can we do? Well, we can return a new result. The payload is going to be, null. So here, instead of undefined, we're just going to put in null. So the result, the user is going to be null because there is no user. But we have this new error. And the error is just going to be an object. Actually, we can actually define this as we can say new error, I error. Okay, and the message can be something like, well, at this point, this is the point, the part that I'm trying to get at, is that now we can do something very cool. So we can now bring in our, we can type something out, and we can say something like, with our string in here, we're going to say, we'll bring in our error codes dot database dot duplicate dot text. So we can say something like error, say duplicate, I don't know, error duplicate. Sure, why not? And in the code, well, that's coming from error codes dot database dot duplicate dot number. Cool. So now we have our error code. Okay, let me bring this away. So let me put this on multiple lines so we can see it easier. So we have this error where the first thing is going to be the message, and this message is kind of crappy. I don't know what kind of message I should put in here. We can even unify the messages if we wanted to, have a way to make the messages be similar. So no matter if you're using Mongo or MySQL, you'll get the same messages, the same error codes. Everything's the same, except the way the error came about is going to be different for Mongo and MySQL. But we'll have a unified way. So here we say error duplicate. This is all it's going to say, because remember, this text is just a string, and it's going to say duplicate because that's what you put. So we say error duplicate, and there's the error number. So if we try it and everything went well, cool, we return this new user and there's no error. Beautiful. However, if something crazy went here, like some kind of error, we're going to catch it in here. What we're going to do now is instead of just like blindly saying, hey, an error occurred, I'm gonna die now. What we can do now is we can create error messages for very specific error codes that's going to happen for different data layers. It just so happens that in MySQL, we get a 1062 error on this error number. Cool. Now, in the case, so this is like the default case, we still haven't supported that error code. We're just going to return a new, this I error. The message is going to be unhandled error, and then we'll just type e dot the code, and then we'll do a hyphen, and again we can do this in a number of different ways, and we're going to have to fill out this entire was it error ERR number. Okay, and there's the message, and then I'm gonna bring in the error, the code. Okay, and basically as we test out our backend, we're going to figure out all the different various error codes. In fact, you can actually pull up all of the error codes from the documentation, and then you can create your special error cases for each one. This way, the error codes are always going to be unified. If it's a duplicate, we're always going to get 1000, because that's the error code that we use. If we go back to our error codes here, you'll notice that we have the number of 1000 and the text is duplicate. So whether you're using Mongo or MySQL, the error code and the name is always going to be the same. Okay, cool. So now how do we use this? So now you'll notice that create user actually returns a result now. And if we hover over this user, it's no longer a user, it's a result. So now we can do something like this using something called destructuring. We can either grab the payload, and then we can grab the error like this, something separate. Okay? So now we have a payload now. So instead of a user, we have this payload. And if we wanted to, we can do an aliasing. So do a colon, and then we can call this user. This is called aliasing. So we can change the name of the variable from payload to user. So now it makes sense over here. Cool. So now we no longer have to really do a try catch. Well, we can still do a try catch. If for some reason this entire thing still explodes, at this point, it's safe to say that this is an internal error. And then here we can send back an error if we wanted to, saying an internal error has occurred. But we'll just do a 500 we'll remove this, and we'll just do an error log here, and then 500. But if we're in here, we can probably blame the user. And so by us blaming the user, we can do a couple things. So the first thing is we're going to say, okay, so if the error exists, okay, so if there is in fact an error, we're going to say response.status. We're going to say a 400. There was a bad request. Something happened here. So we're going to say JSON, and then we're just going to send back the error, because the error is going to have the message and the number. Else, everything seems to have gone okay. And we'll bring that in. Okay, just like that. So here we have this response. So if an error exists, status 400 bad request, JSON, we're going to send back the error. Because remember, this error is this I error, and that itself is an object which has two properties, message and code. So that's good enough for us for now. If the error, however, is undefined, then it must be the case that the payload should be good to go. And if that's the case, well, here we go. Status 201, and we're going to send back the user. Great. So let's kill this. Let's run this. Do our post now. Hit send. Cool. Now we get a 400 bad request. Error duplicate. Code 1000. Amazing. See, look at that. Now we have a bad request, which is true. The user did a bad request. So error duplicate. Cool. And you'll notice that over here it's not exploding or anything like that. In fact, let's start getting rid of some of these console.logs. So I want to get rid of this one. We don't want to see it anymore. I think I kind of made the point there. And then in our catch, I only want to log it if we've never seen the error before. If we've seen the error before, we don't care. Okay, so let's run this again now. Look how clean this is going to look now. So I run this. I get this error duplicate. Great. And if I have a brand new user, polymorphic 5, I have to change the email now. 5 like that, hit send. I get a 201. Here's a user ID. And again, we're seeing the password, which is terrible. Don't do that. But notice that now the backend is very, very clean. Very, very clean. Okay, cool. This is all working. Okay. Okay, cool. So what happens if in the middle we kill this? We no longer have a connection. Ah, so it died over here. Okay, cool. So this died all on its own. Amazing. Great. Okay, cool. So that is, I think that is then good enough for here. Now, as you can see that we obviously have a whole lot more to do, because all we've done is set up the first part, which is just to create a user. However, this is now engineered to take on a multitude of things. So the first thing is, if we try to create a user and it fails, you know, for example, it's a duplicate entry, boom, we got that all right here on lockdown. Amazing. So this is pretty cool. Okay, this is pretty cool. So so far so good. We get some really good stuff. Okay, cool. So other than that, I hope this is starting to make sense of like what the level of requirements is going to take in order to achieve writing a really good backend service for our data layers. So this is what it's going to take to create a user. We have these promises, so there's some possible errors that can occur. We're going to try and catch them, but now we're going to catch them smartly. Instead of a super generic crash, we are now going to catch them based off these error codes. Now, these error codes is very specific to MySQL. However, we basically, using these error codes that we've defined, we're remapping them to something that we can use for different services, whether it's MySQL, Oracle, SQL Server, MongoDB, Postgres, whatever. Okay. So that's the beauty of this, is that we've remapped the error codes. So now any data layer that we use that throws its own errors, we can then take those error codes, try to see if we can find if an error code already exists that maps to it, and then we can use that. That way we always have a unified error API. And so that's basically what we're doing here. Now, again, you could look at this and be like, I feel like this is over-engineered. But I honestly, we're missing a lot. But I think this is strong. This is pretty strong. So hopefully that makes sense. I know I'm a little over time now, 5 minutes. So thank you for guys for sticking around. Hopefully you've been enjoying this backend stuff. And then on Monday, hopefully we can get into some MongoDB. And then we're going to, I just want a way for Corbin to show how we can use MongoDB, how to set it up and use it to create users and stuff like that. And have him create a service. And you're going to see how badass it is, where all he's going to have to do is go here, make a folder called MongoDB, and then create a Mongo user service. And then theoretically speaking, if everything goes well, this file, specifically this route, should never be touched. It won't be touched because this is super abstract. There's nothing in here that's concrete. Look at this. I feel like this is really nice code. Okay, again, just looking at it, we're getting the user service, which we don't know if it's Mongo or MySQL based. We're going to try and do this dangerous task of creating a user. We're going to get the payload, maybe. We're going to alias it to user, and then there's an error object that can come with it. If the error exists, we're going to throw a 400. We're going to say that, hey, that's a bad request, and we send back the error because it's a class which is going to be serialized into a JSON object. And if there is no error, then we can say for sure, okay, yeah, the payload was created successfully, and here it is. And we do a 201 because when you use a post and you're trying to create something, a 201 is the proper status code to use. Now, if something explodes over here and we didn't have any foresight or we didn't think about it, then this is our last ditch effort. At this point, we have an internal server error. We honestly have no idea what just happened. Something exploded and we don't know what it is. So in that case, we can tell the user, hey, this is not your fault. This is our fault. And our server is going to log to the console what the error is, and then we as the developers can go in and be like, okay, so what the hell happened? And then we can try and debug it from there. Okay, so at this point, this is a 500, and we have no idea. Something exploded that we weren't expecting. Here, these are controlled explosions. An explosion can happen, but it's in a controlled way. This is a runaway explosion. Our server exploded, and we have no idea why. So it's an internal error. Something happened, and God knows what. Okay, so with that, if you guys have any questions, let me know. And on Monday, hopefully, if Corbin's available, we can start doing the Mongo. And then once we introduce Mongo, we're just going to build the rest. I'm not going to explain a whole lot because at this point, we only have create user. We still need to get all of this done. And so I took my time with this so that once you see me rapidly build all of these, it should just be straight review. And again, if you have any questions, just rewatch the videos if I go too fast or whatever. But I can guarantee you that when we get to this part, I'm not going to go slow. I'm going to build all of this in one session. I'm just going to go through the whole thing. And I'm going to explain my thinking process of why I'm doing certain things. And you're going to see me build it basically looking something like this, how we built this. This is going to basically be our template of how we're going to be building stuff, structured correctly. Okay. Again, you can think of this as over-engineered, but I honestly don't think it is. I think this is a safe route where it's not going to bite you in the butt. And the beautiful thing is when you try to consume the service, look how clean your code is. It's very simple. It's very simple. If you want to expand on this and do stuff, there's very few things that you need to keep an eye on, because this is super easy code to maintain, because the bulk of our logic is here, and we've put guards in place to ensure that any possible error can be caught, and we can deal with them appropriately. Okay. All right. So just before I end here, I'm going to quickly push this to GitHub. Completed MySQL users service dot create user function added service locator updated index.js entry logic. Okay, and we push to GitHub. Cool. So now you guys should have access to that, and that should be it. Now you guys should have all that. We still need to talk about routes, which we haven't done that, but we'll probably talk about that next time when we're going to restructure the way index.js works so we can get rid of this. All right, with that, thank you everybody for sticking around. I know this was a pretty long session, so hopefully you guys found this entertaining and useful. And if you guys have any questions, remember the Discord server is always there. So with that, have a good weekend, and I will see you guys on Monday. All right, thanks everyone. Bye.